Good evening, my dear students in Year 1. Our lesson today in Geometry branch is division of a line segment. Division of line segment has two types. The first one is called the internal division. If C belongs to the line segment AB, where C divides AB by the ratio M2 to M1, and if we suppose that A equals x1, y1, B equals x2, y2, and the ratio of division in this case is M2 to M1, then the point C using the Cartesian form is m1x1 plus m2x2 over m1 plus m2, m1y1 plus m2y2 over m1 plus m2. This is called the Cartesian form of point of division of the line segment AB. There exists another form which is called vector form. If you look to the next three figures, figure 1, 2, and 3, if we suppose that vector OC by vector R, vector OA by vector R1, vector OB by vector R2. In the first figure, vector CP, point C belongs to the line segment AB. Point C in figure 2 and figure 3 belong to straight line AB and doesn't belong to the line segment AB. Anyway, vector OAC over vector CB equals M2 over M1. Cross multiplication. M1 times vector AC equals M2 times vector CB. Vector AC equals C minus A, vector CB equals B minus C. Replacing vector C, vector A, vector B, write instead of them vector R, vector R1, vector R2 respectively, and distribution M1 and M2 inside the two brackets. M1 times vector R minus M1 times vector R1 equals M2 times vector R2 minus M2 vector R. Moving M1 vector R1 to the right hand side using the other sign, and moving M2 vector R to the left hand side using the other sign, you will find that M1 vector R plus M2 vector R equals M1 vector R1 plus M2 vector R2. Taking R as common factor in the left hand side, so vector R between brackets M1 plus M2 equals M1 vector R1 plus M2 vector R2. So to find vector R, divide both sides by the brackets M1 plus M2. You will find that vector R equals M1 vector R1 plus M2 vector R2 over M1 plus M2, which is called the vector form of the point of division of AB. Now, we talked before that if C is midpoint of AB, where A equal x1, y1, B equal x2, y2, so the point C will be equal x1 plus x2 over 2, y1 plus y2 over 2. This is Cartesian form. But using the new form vector form, the ratio between AC to CB is m to n because they are equal. So vector R equal m vector R1 plus m vector R2 over m1 plus m2, which is mean m plus m. Taking m as common factor, m between brackets vector R1 plus vector R2, crossing m up and down together, so vector R equals vector R1 plus vector R2 over 2. This is the vector form of midpoint of line segment. Remark, if I have triangle ABC, where A equal x1, y1, B equal x2, y2, C equal x3, y3, and M is point of intersection of its medians, which divides each of them by ratio 1 to 2 from the base, or 2 to 1 from the vertex, then the coordinates of M equals x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. M also, we can call it by point of centroid. Second, the external division. If C belongs to the straight line AB and doesn't belong to the line segment AB, then C divides AB externally by ratio M2 to M1. Also let that A equal x1, y1, B equal x2, y2, and the ratio of division here is M2 to M1. Then C using the external division will be m1x1 minus m2x2 over m1 minus m2, m1y1 minus m2y2 over m1 minus m2. Remarks. Number 1. To prove that 3 points A, B, and C are collinear, we have many methods. We can prove that the 3 points are collinear using the slope idea as you took before, slope AB equals slope AC, or using the distance formula, the longest distance, for example AB, equal the sum of the shortest two distance BC plus AC, and by using our method vector, we can prove that vector AB equal constant K times vector AC. Remark number 2. If I don't know the ratio between M1 and M2, which determine the point of division, if it's internally or externally, if the division internally, so the ratio M2 over M1 is positive, and if it's negative, so the ratio between the 2 points A and B is externally using the point C. Now let's take some examples. Example number 1. If A equal to -1, B equal -3 and 4, find the coordinates of the point C, which divides line segment AB internally by the ratio 3 to 2 in the vector form. First, I'll try to draw a line segment AB, and I divided it into two parts, the ratio between them 3 to 2 as he said, 3 from A and 2 from B as he said also. So using the vector form, I can write that vector AC over vector CB equal 3 ratio 2. Vector AC equals C minus A, vector CB equal B minus C over 3 equal 3 over 2. Crossing multiplication, 2 times vector C minus 2 vector A equal 3 vector B minus 3 vector C. Collect the like terms, which is mean that moving 3C to the left side and 2A to the right side using the other sign, we will prove that 5C equals 3 vector B plus 2 vector A. So 5 vector C equals 3 times -3 and 4 plus 2 times 2 -1. It's gonna be -5 and 10. Divides by 5, so vector C equal -1 and 5, which is mean that the coordinates of the point C are -1 and 2. Next example number 2. If A equal -3, -7, B 4 and 0, find the coordinates of the point C, which divides vector AB by the ratio 5 to 2 internally. So here you can answer this question using the vector form or Cartesian form as you want. Drawing also the line segment AB and divides by C by the ratio 5 to 2 from A, we can say that M1 equal 5, so the point B is x2, y2. M2 is 2, so the point A is x1, y1. Using the rule of Cartesian form, m1x1 plus m2x2 over m1 plus m2, m1y1 plus m2y2 over m1 plus m2 to find the point C. So 5 times 4 plus 2 times -3 over 5 plus 2, comma 5 times 0 plus 2 times -7 over 5 plus 2. So at the end, C equals 2 and -2. This is the point which divides the line segment AB internally by the ratio 5 to 2. Next example number 3. If A equals 6 and 3, B equals -7 and 2, find the coordinates of the point C, which divides AB by the ratio 3 to 2, but this time externally. Also, I will draw the line segment AB, and where I should put C. He said that C divides AB, so C will be put nearest to the second letter B, and the ratio from C to A is 3, and from C to B is 2, as he said. So here, in this case, C divides AB externally, so I will use the rule of external division, which is C equals M1x1 minus M2x2 over M1 minus M2, M1y1 minus M2y2 over M1 minus M2. If M1 is 3, M2 is 2, so the point x1, y1 is B, point x2, y2 is A. So 3 times negative 7 minus 2 times 6 over 3 minus 2. 3 times 2 minus 2 times 3 over 3 minus 2. So C will be negative 33 and 0. This is the point which divides AB externally by the ratio 3 to 2. Next example number 4. A equals 5 and 2, B equal to negative 1. Find the ratio by which vector AB is divided by the points of intersection of the straight line AB with the 2x, showing the type of division in each case, then find the coordinates of the division point. First, let that x-axis intersects AB at point C, which is equal x and y. As you know that any point belong to x-axis, its y coordinate is 0. So, in the opposite figure, AC ratio CB equals M2 over M1. So this point C belongs to x-axis, as I said, it's equal x and 0. I will take the second coordinate 0, which is y equals M1y1 plus M2y2 over M1 plus M2. After substituting by y equals 0, M1 times 2 plus M2 times negative 1 over M1 plus M2, crossing multiplication. So 2M1 minus M2 equals 0. 2M1 equal M2, so the ratio M2 over M1 equal 2 over 1, which is mean 2, and this ratio is positive because it's greater than 0. So the type of this division is internally, and the ratio of this division is 2 to 1. To find the point C, we had to find the coordinate x. X equal M1x1 plus M2x2 over M1 plus M2. Now M1 equal 1, M2 equal 2. Substituting in the rule, 1 times 5 plus 2 times 2 over 1 plus 2 is gonna be 3 and 0. So the point which divides AB, which is belong to x-axis, is C equal 3 and 0. Now we'll take the other point which belongs to y-axis, and as you know that any point belong to y-axis, its coordinate is 0 and 1. So if the straight line intersects y-axis at d x1 y, which is equal 0 and y, if you look to the opposite figure, vector AD over vector DB equals M2 over M1. So the point 0 and y, which is D, I'll take the x coordinate, which is M1x1 plus M2x2 over M1 plus M2. 0 equal M1 times 5 plus M2 times 2 over M1 plus M2. Crossing multiplication, you find that 5M1 plus 2M2 equals 0, which is mean that 5M1 equal negative 2M2. So M2 over M1 equals negative 5 over 2, which is less than 0. So the ratio of division here is negative, which is mean that the type of this division is external. So the point D divides line segment AB externally by the ratio 5 to 2. The point D itself, its y coordinate equals M1y1 minus M2y2 over M1 minus M2. M1 equal 2, M2 equals 5. So y equal 2 times 2 minus 5 times negative 1 over 2 minus 5. So the point of division is 0 and negative 3. The last example, number 5. ABCD is a parallelogram. If A equals 7 and negative 2, B equals 15 and 4, C equals 9 and 6, find the coordinates of the point of intersection of its diagonals AC and BD, then find the coordinates of the point D. After drawing the parallelogram ABCD, suppose that the two diagonals AC and BD intersected at M, and since the figure is parallelogram, so the two diagonals AC and BD bisect each other, which means that M is midpoint of AC and also midpoint of BD. I'll find the coordinates of the point M using the Cartesian form of midpoint of AC, which is x1 plus x2 over 2, y1 plus y2 over 2. So M equals 7 plus 9 over 2 and negative 2 plus 6 over 2. So the point M will be 8 and 2. This is the point of intersection of the two diagonals AC and BD. This point is also point of intersection of BD. But in this case you have B and you have M. So D equal double the midpoint minus the other point B, which is mean that D equal 2M minus B. 2 times 8 and 2 minus 15 and 4. So in this case will be 1 and 0. So the point D equal 1 and 0. That's all. Thank you, my students.